Hi guys, welcome to the continuation of our lesson on structural concrete design part 2. So let's go to where we stopped in our previous video. So we are going to look at common causes of cracks in concrete. And before we start, we need to emphasize on the fact that nearly all concrete cracks. However, not all cracks causes damage. Why? Cracks occur in concrete when it is subjected to tensile stress or tensile strain, and the tensile stress exceeds the tensile strength of the concrete, or you might say the tensile strain exceeds the tensile strength capacity of the concrete. So usually concrete has very low tensile strength. So whenever you subject it to a load and the load exceeds the tensile strength of the concrete will crack. But like I said, not all crack will causes damage. So it therefore follows that the tensile strength of concrete is its resistance to cracking and therefore is extremely important. Remember that cracking is caused by some form of tensile stress or tensile strain, and strain is usually change in length divided by original length. Hence, there is some form of movement. It is a movement that causes a crack. The fact that concrete cracks is actually helpful, whether you believe it or not, because it's often a warning sign to tell us that something is wrong, and if we act promptly, it will be good. So what are the causes of concrete cracking? We have structural cracking, and structural cracking are caused by applied load. These are cracks that are caused by applied load, like flexural cracking, like shear cracking, etc. We also have non-structural cracking, which are cracks that are not caused by applied load. They could be early thermal shrinkage crack, plastic shrinkage crack, restraint deformation crack, crack caused by failure of hardened cement paste, crack due to rusting of reinforcement, etc. So let's look at structural cracking. Like we said, structural cracks are caused by applied load, often due to either poor design, member is too thin, or insufficient reinforcement, or error in calculation, or poor detailing or poor workmanship. Steel may not be adequately supported, causing a reduction in the effective depth, which causes a reduction in shear capacity and bending moment capacity of a concrete. So all this poor detailing or poor workmanship can result in structural cracking. Now let's look at this beam loaded. You can see this beam loaded in flexure. You can notice a hawking flexure. The beam is hawking like this, is hawking upward, and so this is a tensile zone. Because these are tensile zone, you can see cracks. You can see some cracks on the tensile zone. Now this is a compressive zone. You can see the crushing of the concrete. Crushing of concrete. This is caused because the applied flexural load is higher than the compressive strength of the concrete. Also note the localized buckling failure of the longitudinal reinforcement at the bottom steel. So you can see this is buckling failure. The reinforcement fell. So these are structural cracking. For seal on structural cracking, you can see this one. This beam is low so that it is sacking downward, and the same thing happen. You can see cracks here on the tension zone and crushing of concrete on the compressive zone. Now this is shear cracking of reinforcement concrete. You can see there is a load here and there is a shear cracking here. You can this is a load here, this is a load. So the shear that exists between them, it causes a crack here in the concrete. So still on structural cracking, this is an unusual example of structural cracking. You can see longitudinal splitting of it. Look at this. This is actually a column, but you can see a splitting and here the reinforcement is. There is actually reinforcement at this place, and because the cover due to reinforcement is not adequate, and so the concrete reinforcement is not able to transfer the load adequately to the concrete because there's actually a bonding between reinforcement and concrete to form reinforced concrete. So in the absence of that adequate cover, you can see the cracking of cover to reinforcement. So that is why when we are doing design, we should be able to provide adequate cover to reinforcement. So let's look at non-structural cracking. Non-structural cracking in concrete is caused when the concrete cracks or shrink and is restrained from doing so, either fully restrained or partially restrained from doing so. So when concrete want to shrink or want to contract and there is a restraint from it to contract, you will now have those cracks. Now such restraint is usually provided either by the existing ground in the case of foundation or floor slab, or by the previously cast concrete. So if you have a concrete wall and you are casting another concrete, and this concrete wall is already hardened, it cannot move. So when this one wants to shrink, the other one is restraining it. It will cause, or you start having a non-structural cracking. So the restraining effect of the ground or previously cast concrete creates tensile strain. If the tensile strain exceeds the tensile strain capacity of the concrete, concrete will crack. It is common practice to control such cracking by providing seal reinforcement. So this seal reinforcement is provided to distribute the tensile strength within that region and avoid the crack, or sometimes, and although they might be cracked, but the crack will be within acceptable limit for the concept purpose of aesthetics, durability, and functional requirement. As an alternative to the provision of large areas of steel reinforcement, the degree of restraint can be reduced by providing movement joints. So when you provide movement joint, or you call it expansion joint, this will result in smaller giving space, so that when restraint happens, whether expansion or contraction, the concrete mass is able to do that. So you can see example of a plastic shrinkage crack. Look at the sample of plastic shrinkage crack, which is common form of cracking in thin layer slabs. They are vulnerable to this. What happened that is occur when bleeding of concrete occur. When you cast this concrete and bleeding occur, bleeding means that the concrete will evaporate, or sorry, the water will evaporate. So when it evaporates, tensile stress are caused when the bleeding water evaporates from the surface of the slab in hot, dry, sometimes windy conditions, leaving high cement content material with little coarse aggregate. This will result in shrinkage. They will shrink. So this is shrinkage cracking. You also have crack due to restraint deformation. So you can see a mass here because the mass of concrete here is very much. So when expansion want to take place, there is no space for expansion, so it will cause crack. And this can easily be avoided by production of expansion gap. Now let's look at if the concrete was free to shrink, or it was unrestrained, there will be no problem. Unfortunately, most concrete are restrained by the previous pour or the ground on which it is cast. So this creates tensile strain leading to cracking. This form of cracking is called early thermal cracking. So let's look at cracking due to corrosion of reinforcement. If you look at this circular column, you can see a line here, a line of crack. This line of crack is caused by corrosion of the reinforcement. You can see the reinforcement inside the crack has been corroded, and because of the corrosion, the reinforcement will expand, and as it expands, it cracks the concrete. So you can see this corrosion color from the reinforcement coming out here. So this is a crack due to corrosion of reinforcement, and it's not something that we really desire. That's why we need to provide quality, adequate and quality cover to reinforcement to preserve our concrete. Now, when surrounded by good quality concrete, when the reinforcement is surrounded by good quality concrete, the steel reinforcement is passivated. That is chemically protected against corrosion. Now, the passivating film or protective coating exists around the reinforcement. They are actually calcium hydrate crystal combining with iron oxide on bar surface, and that gives you this high resistant layer, means no correction, no corrosion. So that means concrete itself is able to protect the reinforcement from corrosion. Steel reinforcement, however, steel reinforcement can be depassivated due to carbonation and or exposure to chloride. So when chloride penetrates or carbonation takes place, they can depassivate the reinforcement and make it expose it to cracking, to rusting. So look at, there are some tutorial questions here that you can look at and see if you can answer them. The questions are typically based on lesson structural concrete design 2, the first part and the second part that we have looked at. So thank you very much for listening to this lecture to the end, and the Lord will bless you. If you have any question, just leave it on the comment section. I might be able to answer it. Thank you very much.